Internet of Things or IoT. What is Internet of Things? Since the coining of the term in 1999, the Internet of Things has transformed from a mere vision to a palpable reality. This can be attributed to the extensive use of the Internet protocol, the rise of ubiquitous computing, and the continued advancement of the data analytics, among other drivers of development. By 2020, it is estimated that there will be 20.4 billion devices connected to the IoT. Despite its continuing expansion, however, the IoT remains to some degree an obscure concept, something that's often referred to in abstract terms even as it provides manifest benefits. The Internet of Things can be described as an extension of the Internet and the other network. Madidescribe ang IoT as an extension of the Internet at sa iba pang network connections to different sensors and devices or things, affording even simple objects tulad ng light bulbs, locks, and vents a higher degree of computing and analytical capabilities. Interoperability is one of the key aspects of the Internet of Things that contribute to its growing popularity. Connected or called smart devices as things in the IoT are often called have the ability to gather and share data from their environments with other devices and networks. Through the analysis and processing of the data, devices can perform their functions kahit anong tulong mula sa human interactions. Given the ever-increasing number of connected devices, the IoT is patuloy sa pag-evolve, adding different layers to the data that is already being shared and processed, and giving rise to the sophisticated algorithms that result in improved levels of automation. And because of the variety of things that can be connected to it, the IoT has enabled diverse application for individual user and entire industries alike. How does the IoT work? The things that make up the IoT can be anything from a wearable fitness tracker to an autonomous vehicle. So, kahit ano pang function yan, they serve for users. These devices must have the following components for them to properly operate as parts of their respective IoT systems. Sensors. Sensors are everywhere. They are in our homes and workplaces or our shopping centers and hospitals. They are embedded in smartphones and an integral part of the Internet of Things. Sensors have been around for a long time. The first thermostat was introduced in the late 1880s, and infrared sensors have been around since the late 1940s. So, the Internet of Things and its counterpart, the Industrial Internet of Things, are bringing sensor usage to a new level. Data is first collected from the environment for the IoT systems to begin processing. It is collected by sensors in devices that can measure observable occurrences or changes in the environment. The kind of data being measured by the device depends on its function. It can be a person's pulse in the case of a business tracker, or the distance of the nearest object in that of an autonomous vehicle. Broadly speaking, sensors are devices that detect and respond to changes in an environment. Inputs can come from a variety of sources such as light, temperature, motion, and pressure. Sensors output valuable information, and if they are connected to a network, they can share data with other connected devices and management systems. There are types of sensors. Temperature, one of the most common and most popular sensor is temperature sensor. A temperature sensor, as the name suggests, senses the temperature. For example, it measures the changes in the temperature. The other example is humidity sensors. This type of sensors measure the amount of water vapor in the atmosphere of air or other gases. Humidity sensors are commonly found in heating, vents, and air conditioning system in both industrial and residential domain. They can be found in many other areas, including hospitals and meteorology stations to report and predict weather. The other is pressure sensors. A pressure sensor senses changes in gases and liquids. When the pressure changes, the sensor detects these changes and communicates them to connected systems. Common use cases include leak testing, which can be a result of decay. Pressure sensors are also useful in the manufacturing of water system as it is easy to detect fluctuations or drops in pressure. The other example is proximity sensors. Is an non-contact type of sensors that detects the presence of an object. It can be implemented using different techniques like optical, like infrared or laser, ultrasonic, Hall effect, or capacitive. Another example is level sensors. It is used to detect the level of substances including liquids, powders, and granular materials. Many industries, including oil manufacturing, water treatment, and beverages and food manufacturing factories, use level sensors. Waste management systems provide a common use case as level sensors can detect the level of waste in a garbage can or dumpster. Another example is accelerometers. Accelerometers detect an object's acceleration. For example, the rate of change of the object's velocity with respect to time. So, accelerometers can also detect changes to gravity. Use cases from accelerometers include smart pedometers and monitoring driving fleets. They can be also used as anti-theft protection, alerting the system if an object that should be stationary is moved. For example is gyroscope. These sensors measure the angular rate or velocity, often defined as a measurement of speed and rotation around an axis. The other one is gas sensor. This type of sensors monitor and detect changes in air quality, including the presence of toxic, combustible, or hazardous gases. Industries using gas sensors, including mining, oil and gas, chemical research, and manufacturing. A common consumer use case is the familiar carbon dioxide detectors used in many homes. The other example is infrared sensors. This is light-based sensors that are used in various applications like proximity and object detection. IR sensors are used as proximity sensors in almost all mobile phones. There are two types in IR sensors, transmissive type and reflective type. Last example is optical sensors. Optical sensors convert rays of light into electrical signals. There are many applications and use cases for optical sensors. In the auto industry, vehicles use optical sensors to recognize signs, obstacles, and other things that a driver would notice when driving or parking. Optical sensors play a big role in the development of driverless cars. Optical sensors are very common in smartphones. For example, ambient light sensors can extend battery life. Also used in biomedical field including breath analysis and heart rate monitor. The other component is connection and identification. Here, the data must be communicated from the device to the rest of the IoT system, be it to a computer or to another device. And for this communication to have any meaning, a device must have a unique identifiable presence on the internet accomplished through its own IP address. Actuator is the other component. Most IoT devices are capable of doing their primary functions without physical interaction with their users. So IoT devices should be able to take action based on data from their sensors and subsequent feedback from the network. For example, a smart light bulb can turn on upon the command of its users even when the user is miles away. In the same manner, a bulb in a smart factory can automatically open or close according to data gathered by its sensors along the production line. Even though the devices are usually built with automation in mind, other technologies must be in place for IoT systems to work. The other component is IoT Gateway. The IoT Gateway acts as a bridge for different devices or data to reach the cloud. It also helps in translating the different protocols of the various IoT devices into just one standard protocol, um, and in filtering out unnecessary data gathered by the devices. The cloud. The cloud is where all the data from different devices is gathered and where software can reach this data for processing. Because of data processing happens in the cloud, it lessens the burden on individual devices. User interface is the other component. The user interface communicates to the users the data gathered by the devices and allows the users to make the necessary commands to be executed by the devices. The other components is device to device. This model represents how two or more devices connect and communicate directly with one another. Communication between devices is usually achieved through protocols such as Bluetooth, Z-Wave, and Zigbee. This model is often found in wearable and in-home automation devices, where small packets of data are communicated from one device to another, as, as with a door lock to a light bulb. Other component is device to gateway. So before connecting to the cloud, the IoT devices can communicate first with an intermediary gateway device. The gateway can translate the protocols and add an additional layer of security for the entire IoT system. In the case of a smart home, for example, all smart devices can be connected to a hub. or that you call the gateway, that helps the different devices to work together despite having different connection protocols. Last component is backend data sharing. Essentially extends the single device to cloud communication model so that IoT devices and sensor data can be accessed by authorized third party. This is an extension of the device to cloud model. This model allows users to gain access to analyze a collection of data from different smart devices. And for example, a company, for instance, can use this model to access information from all of the devices working inside the company building as organized together in the cloud. This model also helps lessen issues with data portability. What are the applications of the IoT? Just as the internet at large affects a broad spectrum of users, so does the IoT. Depending on the scale of connectivity and the number of devices involved, the IoT can have significant and specific applications, be they for a single user or for an entire city. There are common applications of the IoT including the following. People and homes. People make direct use of IoT devices through technology that can be worn, such as smart watches and fitness trackers and devices that help make receiving and collecting information possible in real time. Application light to households. So IoT devices can be used for a more connected, efficient, and conveniently run home. The different aspect of a connected home can also be remotely accessed and controlled by home owners through a computer or a handheld smart device. Automobiles. Sensors within a moving vehicle make it possible to collect real-time data about the vehicle and its surroundings. Autonomous vehicles use different sensors in combination with advanced control systems to assess their environments and consequently drive themselves. Yes, on a large scale, with the adoption of IoT technologies, business can be more cost effective, efficient, and productive. For example, office buildings can be fitted with sensors that can monitor elevator traffic or overall energy consumption. So the different industries naturally have different application of the IoT. In the healthcare industry, IoT devices may be used to gain instant and accurate updates about the condition of patients. While in the retail industry, the IoT devices may be developed to help shoppers locate products and to monitor the inventory. Cities. The combined uses of different IoT devices can cover urban and public areas. So IoT devices can gather data from and affect its environment to help manage the various aspects of city governance such as traffic control, resource management, and public safety.